Hello and welcome to this video that goes through exercise 9C of the AS Mechanics and Stats Edexcel textbook. This video will go through questions 6 to 10. So the first question we have is: a particle moves in a straight line from a point A to a point B with a constant deceleration 1.2 meters per second squared. The particle takes 6 seconds to move from A to B. The speed of the particle at B is 2 meters per second and the direction of motion of the particle has not changed. Find the speed of the particle at A. So if you want to visualize this, essentially a particle starts moving from A and will move to B. It tells us that the acceleration, constant deceleration, so A, if we take this direction as positive, A is going to be 1.2 meters per second squared, and T is equal to 6 seconds to go from A to B. At B, we know that the speed of the particle is going to be 2 meters per second. So first of all, it wants to find the speed of the particle at A, which is going to be our initial speed. So the way we set this up is we should always write SUVAT for SUVAT. We don't know the distance, so we're not going to use this equation here. We're not going to use S. U is what we want to find, so we'll call that U. Our final speed at B is equal to 2 meters per second. Our acceleration, because we're deceleration, so therefore we take this as a negative 1.2 meters per second squared, and our time is equal to 6 seconds. From here we're going to use the SUVAT equations. You are given these in the exam, so v squared equals u squared plus 2as, v equals u plus at, s equals ut plus a half at squared, and s equals u plus v over 2 times t, and the final one, s equals vt minus a half at squared. From here we're going to use the equation that doesn't have s, which is v equals u plus at. So v equals u plus at. We can substitute in our value, so we have 2 equals u minus 1.2 times 6. Again, the negative comes from the fact that we have a negative acceleration. And then from here we're going to plug our numbers. Well, first of all we're going to rearrange, so it's going to be 2. If we do 1.2 times 6, we get 7.2. So 2 plus 7.2 is equal to u, and that means that u is equal to 9.2 meters per second squared. If we move on to B, it wants to find the distance from A to B. So again, we could use SUVAT, SUVAT. This time we want to find S. We now know our initial speed is 9.2. We know our final speed is 2. Our acceleration is 1.2, and our time is 6. Okay, we can put the units in for completeness. And here we want to find what the S is. Now, in this situation, you have the choice. You can use any equation, any of these equations. I would be careful, and I wouldn't use anything that you have calculated in A, simply for the fact that if you get A wrong, then you run the risk of also getting B wrong. So if possible, unless you have to, of course, I would not use U in this equation, but you're more than welcome to use any formula essentially to find what S is. So the equation that doesn't have U is S equals Vt minus half At squared. So S is equal to Vt minus half At squared. For here we're going to plug in, so S is equal to 2 times 6 minus a half times minus 1.2 times 6 squared. From here we're going to plug in our numbers, so it's S is equal to 12, and then we plug in a half times minus 1.2 times 6 squared, which gives us an answer of minus 21.6. From here we add our answers together, so S is equal to 12 plus 21.6, which is equal to minus 33.6 meters as our final answer. So our distance from A to B is 33.6, and that gives us our answer for number 6. Question 7: a train travelling on a straight track is slowing down with a constant deceleration of 0.6 meters per second squared. The train passes one signal with a speed of 72 kilometers per hour and a second signal 25 seconds later. Find the velocity in kilometers per hour of the train as it passes the second signal. So for this question, we're going to set up our situation. So we know that we're going to assume it's travelling to the right. This is going to be signal 1, and this is going to be signal 2, and this is our train. travelling along. So we know that the acceleration is decelerating at minus 0.6 meters per second squared. We know that the velocity at this point is 72 kilometers per hour, and we know that the time taken between 1 and 2 is 25 seconds. So the first thing we do is we write our SUVAT. So we write our SUVAT out. We don't know S in this question. We know U is equal to 72 kilometers per hour. We want to know our final speed V. We know that it's a constant deceleration of 0.6 meters per second squared, and we know that time is equal to 25 seconds. Now notice here that, and given in the hint, that we do need to convert to meters per second, so you should always convert any units that you have into meters per second. So if we have 72 kilometers per hour, first of all we can deal with the kilometers. So this is the same as times 10 to the 3, which is equal to little k. So this is 72 times 10 to the 3 meters per hour. And then from here we need to deal with the hour part. So this, what we do from here is we say that the hour, we want to convert this into seconds. So 1 hour, if we think we have 60 seconds in 1 minute, and then we have 60 minutes in 1 hour. So from here we're going to do 60 seconds in a minute and then times that by 60 seconds in an hour, so we get 3,600 seconds. So as it's meters per hour, we need to do 72 times 10 to the 3 divided by 3,600. Remember, we're replacing, so this will become meters per second. Again, the per bit means that it goes underneath, and then we plug that into our calculator. So 72 times 10 to the 3 divided by 3,600 is equal to 20 meters per second. So therefore we can replace our U with 20 meters per second. And then from here we're then going to use an equation. We want to use an equation that doesn't have S inside it. So we're going to therefore use the following equation, V equals U plus AT. So we use the equation, so V is equal to U plus AT. From here we say that V is equal to 20 meters per second plus minus 0.6 times 25. So plugging this in the calculator is going to be 20 minus 0.6 times 25 is minus 15. So therefore our final velocity is 5 meters per second. However, check the question states in kilometers per hour, so therefore we then need to convert this into kilometers per hour. So the way that we do this is we know that there are, for every second this travels, it's traveling at 5 meters per second. So all we do here is we reconvert this back. So instead of dividing by 3,600, we're going to times by 3,600. So it becomes 5 times 3,600. So this tells you essentially how many meters it does per hour. And then we're going to divide it by 10 to the 3. But we'll do the first step first, just because it's easier to see. So it's 5 times 3,600. So this tells you that every second is 5 meters, which means that every hour is going to be 18,000 meters per hour. And then we want to convert this into kilometers. So if we want to convert it, we need to divide by 1,000. So it's 18,000 divided by 1,000, all times 10 to the 3. And then this gives us our answer of 18 kilometers per hour. And that is our final answer for part A. Then the second thing it does is it wants to find the distance between the signals. So again, we're going to write our equation for part B. SUVAT. S is what we want to find. U is equal to 20 meters per second. V we now know is 5 meters per second. Acceleration is 0.6 meters per second, and T is equal to 25. Again, we have found V in the previous equation in answer, so I would not use this one if possible. So if we go back to our formulas that we wrote before, we're going to use S equals ut plus half at squared, as this is the only equation without V. So we plug this in, it's going to be S equals ut plus a half at squared, and then we plug in our numbers, so S is equal to 20 times 25, plus a half times minus 0.6 times 25 squared. From here we plug in our answer, so 20 times 25, which is equal to 500, and then it's going to be a half times minus 0.6 times 25 squared, and that gives us minus 187.5. So our final answer is 500 minus 187.5, which gives us 312.5 meters, and that is our final answer for part B. Question 8. A particle moves in a straight line from a point A to a point B with a constant deceleration of 4 meters per second squared. At A, the particle has a velocity of 32 meters per second, and the particle comes to rest at B. Find the time taken for the particle to travel from A to B. And then part B was find the distance. So here, at this point A, this point B, there's the particle at A, and this will be the particle at B. So here we know we're going to take this direction as positive. We know that the acceleration is going to be minus 4 meters per second squared as it's decelerating. We know that the initial velocity is 32 meters per second, and we know that the final velocity is going to be 0, and this is because the particle comes to rest. So again, we write SUVAT for part A. So our distance we don't know, and we don't need to find. Our initial velocity is 32, our final velocity is 0, our acceleration is minus 4. Again, we can fill in the unit, and our time is something that we want to find, t. So here we're going to use the equation with our s, which is v equals u plus at. So v is equal to u plus at. So from here it's 0 equals 32 plus minus 4 times t. And then we can rearrange. So it's minus 32 equals minus 4t. Minus 32 divided by minus 4 is equal to t. And then we can plug it in. 32 divided by 4 is equal to 8. So t is equal to 8 seconds. And that's our answer for part A. For part B, the distance from A and B, between A and B. So here we can write out SUVAT again. S we want to find. U is 32, V equals 0, A is minus 4, and T is now given as 8. S meters per second. So again, we don't want to use our answer if possible in this one, so we're going to use an equation without t, which in our situation is going to be v squared equals u squared plus 2as. So v squared equals u squared plus 2as. So this is going to be 32 squared is equal to 0 squared plus 2 times minus 4s. And then from here we're going to solve. So 32 squared is 1024 is equal to 0 minus 8s. And then, minus 8s. And then, I am sorry, we need to redo this question. Sorry, so again, it helps if I read the question. So v squared equals u squared plus 2as. So from here it's 0 squared is equal to 32 squared plus 2 times minus 4s. And then from here we're going to say 0 squared minus 32 squared equals minus 8s. So 32 squared is going to be 0 minus 1024 equals minus 8s. So it's a minus 1024 divided by minus 8 is equal to s. And if we put that in, s is equal to 128 meters. And that's our final answer for part B. Question 9. A skier travelling in a straight line up a hill experiences a constant deceleration. At the bottom of the hill, the skier has a velocity of 16 meters per second, and after moving up the hill for 40 seconds, he comes to rest. Find the deceleration of the skier and the distance from the bottom of the hill to the point comes to rest. So if we draw a situation, travelling up a hill, the skier at the bottom, so travelling up a straight line, it's a constant deceleration, so we know that he's slowing down. We know that at the bottom of the hill, the initial velocity is 16, and then at the point where he rests, v is equal to 0 because he comes to rest, and we know that t in this case is 40 seconds for this to occur. So here we have SUVAT. don't know the distance displacement, so we don't need to find this one. Our initial velocity is 16 meters per second. Our final velocity is equal to 0 meters per second. Our acceleration is what we want to find, a, and t is equal to 40 seconds. So here we're going to use the equation that doesn't have s, which is v equals u plus at. So v is equal to u plus at. We're then going to plug in our numbers. So it's going to be 0 equals 16 plus 40a, and then we're going to rearrange as minus 16 equals 40a, minus 16 over 40 is equal to a. Plugging our numbers into a calculator, we get an answer of minus 0.4 meters per second, which is equal to a. Now you can leave your answer like this, but you could also write a short sentence to say that deceleration is equal to 0.4 meters per second squared. Again, the deceleration part, by implying it's deceleration, you don't need to say that it's a negative, because you're already assuming that it will be negative through using the word deceleration. But that is your answer for part A. Then the next thing we look at is the distance from the bottom of the hill to the point where the skier comes to rest. One thing that we don't need here is the angle of the hill, because we're assuming that we're working in the plane of the slope, which essentially means that we're treating our situation, I suppose, as slanted as it's on the slope. So we don't need to worry about any angles or anything like that. That's partly why we're not giving any in the question. So we're given S, U, V, A, T. S is what we want to find. U is equal to 16 meters per second. Final velocity is 0. Acceleration we found is minus 0.4 meters per second squared, and t is equal to 40 seconds. Now we want to find s again. In this last question we found what a was, so we're going to use an equation that doesn't use acceleration, which is going to be s equals u plus v over 2 times t. So s equals u plus v over 2 times t. And then from here, we just plug in our numbers. So s is equal to 16 plus 0 over 2 times 40. So this is equal to 8 times 40 from 16 divided by 2. And 8 times 40 is equal to 320 meters. So our distance is equal to 320 meters. And that brings to the end question 9. Our final question 10. A particle is moving in a straight line with constant acceleration. The points A, B, C lie on this line. The particle moves from A through B to C. Velocity of the particle at A is 2 meters per second, and the velocity of the particle at B is 7 meters per second. The particle takes 20 seconds to move from A to B. Find the acceleration of the particle. So here we're given some points. So this is A, this is B, and this is C. It says that the particle moves from A to B to C. The velocity of the particle at A is 2 meters per second, so we know U is 2, and we know that at B is 7 meters per second, and it takes 20 seconds to cover this. So for part A, we know S, U, V, A, T. We want to find the acceleration of the particle, so we don't need S. Our initial velocity is 2 meters per second. Our final velocity is 7 meters per second. Our acceleration is a, because that's what we want to find, and our t is 20 seconds. Again, we're only focusing between A to B here. We're not given any information about C. So here we're going to use an equation that doesn't have S, which is going to be, as we've used throughout this video, V equals U plus AT. So then we write this out, so V equals U plus AT, and then we plug in our numbers, so 7 equals 2 plus 20A. We rearrange this, so subtract 2 from both sides, we get 5 equals 20A, then we get 5 over 20 is equal to A. So 5 divided by 20 is a quarter, so A is equal to a quarter meters per second squared, which is equal to 0.25 meters per second squared. And that gives us our acceleration. The next step then is we are going to say, we've now got some more information, so we now know that the velocity of the particle at C is 11 meters per second. So we know V is 11 meters per second. and he wants us to say that the time taken for the particle to move from B to C. So here we write S, U, V, A, T. S we don't know, and we don't care about in this question. We're only interested in the time. Our U at this point is 7 because we're starting from B, and our final velocity is 11 because we're ending at C. So this is from B to C. Our acceleration, we're going to use our answer we know is 0.25 meters per second squared, and we know this because the question tells us that the particle moves with constant acceleration. And then the final part is time, which is giving us t. Now in this question, we have to use our answer from part A because we don't have any indication of a distance. So for this question, we are going to use an equation that doesn't have s, which we have just used throughout, which is v equals u plus at. So we're going to use this equation again, v equals u plus at, and we sub it in, so it's 11 equals 7 plus 0.25t. So 11 minus 7 is 4, so 4 equals 0.25t, and then 4 divided by 0.25 gives you 16. So 4 over 0.25 equals t, so t is equal to 16 seconds. And that gives us our answer for part B. If we look at part C, it then wants us to find the distance between A and C. So here we're looking between A and C, and it's going to be S, U, V, A, T. So we want to find our distance S. Our initial velocity at A is 2 meters per second. Our final velocity at C is going to be 11 meters per second. Our acceleration is given to us as 0.25 meters per second squared. And our time here, so here we can work out the time because we know it takes 20 seconds from A to B, and we now know that it takes an additional 16 seconds from B to C. So overall, the time to go from A to C is 20 plus 16, which is 36. So t equals 36 seconds. From here, we can use any equation because we're going to have to use our answers for A or for t. So we can use any one. So s equals ut plus half at squared is perfectly fine, or s equals u plus v over 2 times t. I'm going to use a second equation. So s is equal to 2 plus 11 divided by 2 times 36. And plugging this in, 2 plus 11 divided by 2 is 6.5, times that by 36 gives me a distance of 234 meters. And that brings us to the end of our questions, as we are only doing between, that's the end of question 10, 10 part C. If you have any further questions, please let me know.